Software Engineering Daily is sponsored by Hired.com. If you're looking for a job, Hired.com is the place to start. I've used it personally and it is an excellent service. Software engineers and designers can get 5 interviews in a week with top companies. Go to hired.com/softwareengineeringdaily for a $4,000 bonus upon accepting a job. Thank you, Hired.com. Nick Winter is the CEO and co-founder of CodeCombat, a multiplayer game for learning how to code. Nick, welcome to Software Engineering Daily.
Yeah, thanks for having me, Jeff.
Can you give a brief description for how CodeCombat works?
Well, CodeCombat is a game for learning how to code. So you go in on, all HTML5, Canvas, that sort of stuff. You just start typing code that controls your hero. So self.move right, self.move down. And then it gets more advanced from there as you beat more and more levels, collect gems, kill ogres, level up, get new items, unlock new APIs, and eventually become a decent programmer from scratch.
Where did you get the idea to build CodeCombat?
Well, originally, my co-founders and I were doing a startup for learning how to write Chinese characters. And my non-technical co-founder at the time always wanted to build features, but he didn't know how to code. And he tried everything out there for learning how to code, but it wasn't engaging enough. And so when we were doing our next startup, he's like, man, let's solve learning to program because we know it can be a lot more fun, but the stuff out there, it's not obvious why programming is awesome. You can't build anything at first. Everything is really hard at first. What's the point? And so we decided, well, let's make a game so that the engagement is there from the first moment. You can really see why it's cool to code and you have a reason to learn new syntax, new methods.
How is this different from the type of gamification that other software learning websites like Code Academy feature?
So you can either gamify something, which means to take something that is not a game and make it more game-like, or you can make a game. And you can't really morph from one into the other. So if you are taking lessons and then putting badges and points on them, you're not really going to get anywhere near the level of engagement than if you're taking a game and building actual gameplay. So that was our approach, right? Start with a game that's like, you could legit play this even if you don't care about learning to code and it will be fun. And make sure that the gameplay is coding so that you learn to code while you're doing it.
Interesting. And it's a multiplayer game. So describe the multiplayer aspect.
Yeah, so we have the main multiplayer right now is asynchronous PvP. So the kind of thing where you're writing your hero's AI strategy and then you hit submit and it starts to play against everyone else on the other team. And you can kind of view replays and watch matches and that sort of thing. And you can also select particular opponents and start coding live your code versus theirs to kind of say maybe you lost a match to me. You might adjust your strategy based on what I'm doing, keep running it until you beat me, and then submit again and see who else you beat and who else beats you, and just go that way. Okay. We do tournaments like this. We get beginners in there. We get experienced developers in there and everywhere in between.
So let's talk a little bit more about the gameplay because it may be hard to describe to listeners over audio, how this code actually translates to characters moving around and doing things. So can you describe the gameplay and talk about how closely analogous it is to coding?
Yeah, so we wanted to make sure that you're writing real code as opposed to using drag and drop blocks or a sort of domain-specific language or something like that. So we offer JavaScript, Python, Lua, Clojure, CoffeeScript, and IO. And the ones that aren't JavaScript were contributed by our open source contributors, right? So this is all running in the browser. We're not sending this off to the server. So browsers only run JavaScript. You need to transpile the player's code into JavaScript. And not just a program that runs their code. So you can't just use them scripting and run CPython or whatever to run scripting in the browser because their code needs to plug into our game engine. So if a player types self.move right as that kind of method call to make the hero go over to the right, our transpiler behind the scenes is going to convert that to a Mozilla abstract syntax tree and then generate JavaScript code from that that's kind of instrumented for performance and error handling and all of this stuff. And then that gets plugged into our game engine, which is making ogres run around and spike traps like ready to kill you and gems be ready to be picked up and all that. And it just plugs in and says, all right, let's ask the player what they want to do. Runs the kind of player's plan method, which is now transpiled JavaScript, and then says, okay, the player wants to move over to the right. We do some crazy yielding stuff in our transpiler to make the player code kind of continuation passing style, and then we can interrupt the player's code, go back to our game engine, and when the movement is done, we go back and say, okay, what do you want to do next? So it's this crazy, crazy transpilation process that lets us do real player code, but still in the browser in an easy way that is kind of lets the player it prevents them from making like horrible mistakes like infinite loops and all this sort of stuff, and it still lets them do cool things with just simple lines of code as opposed to having to write an entire self-contained program from the start.
Right, it's kind of a sandbox. It's really interesting, the process you have for transpilation. I imagine that wasn't the first thing that you had when you were like building the first iteration of CodeCombat, was it? I mean, like the Mozilla abstract syntax tree and all these nuanced steps to actually delivering the player movement. What was the initial, I guess, algorithm for translating? So like just to give an example of like the type of movement, like let's say. At the beginning, at the very first level, all you have to do is basically go right. You're just standing there. Your character is just standing there, and you just have to type in this dot move right. So it's basically you get your character to move right, but what you're describing is that all this stuff is going on in the background to translate that simple line of code into the actual player movement. So yeah, I'm really curious how you got to that, all those layers of complexity.
Yeah, so I actually started off with something fairly complex. This is the first stuff that I wrote in CodeCombat. I knew it had to be awesome. So, of course, we just started with JavaScript. So we didn't have the parser to AST to instrumented code step. We just had the let's instrument the player's code step. But very quickly it was like, yeah, let's do that from the abstract syntax tree because we can do all our transformations there instead of on concrete code much better. So that was actually something that happened pretty early on. And then the Python language was like a year and a half in or something like that, and then the others as well. We didn't have the yielding quite figured out at first. So the player's code would be more explicitly like a choose action method. And so you'd say this dot set action move and this dot set target position and then somewhere over to the right. And then the move right was just a shorthand for that. And so the player's code would run once per frame, and if they put this dot move right and this dot move down, they would only move down because they would overwrite whatever they said to do with like the last action. And eventually we did some crazy, crazy stuff to make the yielding work so that this dot move right appears to take time, and then it just moves on to this dot move down when it's ready.
Right. So how do different like autonomous character instructions interleave? Because you have like enemies in the game or you have somebody you're playing against, and I've got my list of instructions that I'm doing, and there's also opponents that have their list of instructions. Are these things like kind of executing at the same time, or is there some notion of interleaving? How do you get the relative time stuff?
It's an entity component system, and so there's an action system, and the action system very basically looks something like for all entities. Well, we call them things because entities is just a terrible variable name because the plural changes and it's so long. I always misspell it, right? So we call them things. So it's something like for all things which act, call thing.chooseAction. And then if thing can act, thing.act, right? And so the components involved actually hold the code for all of these things. So there might be a component for moves or an AI component for auto targets nearest enemy. And so, I'm looping through all my things, and maybe my Ogre Munchkin is going to go and choose to attack my hero. Maybe my gem is just going to sit there and not do anything. And then maybe my hero is going to run the player code and figure out what to do. And maybe the opponent hero is going to run her player code and figure out what to do. So it's all just part of the action system. And so whose turn gets executed is kind of irrelevant, right? Everyone chooses what to do once per frame.
Got it. If somebody plays through CodeCombat, what level of programming skill are you expecting them to have by the end of the game?
Well, right now we have some issues with pacing. Like, things will get hard too fast towards the end of the levels that we've done right now. We're up to about 200 levels. And as you get through the first few worlds and you get into the mountain and glacier worlds, you're writing 100-line long programs, you're using several functions, you're decoding prime numbers, you're interpreting binary, you're writing your targeting AI to put your soldiers in a defensive circle and determine when to use your cleave abilities to go and disrupt the enemy spellcasters. Building and commanding armies, it gets pretty advanced. Not that the average 8-year-old is getting there, but a lot of people that know a little bit more or just really interested will get towards the end. Hey, wait, when do you have more levels? And then they'll go into the multiplayer. And in the multiplayer, especially if you're trying to win one of our tournaments, it gets pretty crazy, right? Like, I tried to win the last one and I'd written the level and I still couldn't win. Like, some guy beat me.
Whoa.
Which was a lot of fun, right? So, and he's, implementing solutions that he adapted from papers that he read, right? Like, at the high end, it gets pretty high, but the progression currently doesn't get most players to the high end.
So people are writing papers about CodeCombat or like AI?
Yeah, so they would implement techniques from AI papers. And then typically if they write their solutions up, it'll be a blog post that we'll link to from our blog, not necessarily paper, because CodeCombat isn't really formal enough for most journals, right?
Well, that's so interesting. So you're saying CodeCombat has, although it has a like kind of restricted, domain-specific language, like where your character can move right or can attack or can defend, or it's still flexible enough to implement like generic AI algorithms.
Sure. You can use anything that's in JavaScript, and for our other languages, anything of the standard libraries that we've implemented in our transpiled versions. You only have, like in the later levels, you may only have like 30 or 50 different APIs that do anything in the game world. That's still a lot. So your AI techniques relating to, I'm going to optimize how I'm gathering coins. I'm going to optimize how I'm building units and commanding them and using special abilities and all of this stuff. Usually most AI techniques are like, there's a much simpler range of things you can do. Like if you're trying to optimize a traveling salesman, it's like, what city do I go to? And here it's like, what control point do I go towards? But exactly where around it do I defend? And am I attacking? Am I shielding? How many types of which units am I sending there? So it's pretty much generic full-blown programming. When you're trying to do anything advanced, it's just maybe I'm not connecting to a database and doing networking, because what would that mean in the context of CodeCombat? Well, we don't know yet, but.
So the early levels of CodeCombat, like I played through, the first 2 or 3 levels, 5 levels, and it was very much just like moving the character around. And it made me curious about how you get from that phase of the kind of like a very specific, restrictive form of just moving characters around to the more generic explanation of how you do coding and how code works and how coding can represent these characters in the level. Can you explain how you sort of onboard the player from kind of just understanding, all you can do is move right or attack to this expansive world of different commands you can enter.
Yeah, so our approach is very different from the approach of a lot of other learn to code things. And what they do is almost always intensive learning, whereas what we're trying to do is extensive learning. So in intensive learning, things are fairly hard. You're spending a lot of time thinking. You're learning a lot of new stuff per unit time. And so this might be, for example, reading like a math textbook or something. Whereas in extensive learning, most of what you're doing is already familiar, and there's a much lower percentage of new stuff. But this allows you to go much faster and do a lot more things per unit time, as opposed to learning a lot more concepts per unit time. And this would be, for example, if you're just doing a math worksheet full of problems that you already know the techniques for, as opposed to just reading the linear algebra textbook or something like this. And what turns out is that you need a mix of intensive and extensive, but you mostly need extensive. Like 90% or more of your time should be extensive. And all the other solutions are like 100% intensive, right? You're not spending enough time practicing the easy stuff. And for good reason, right? Like if you're practicing easy programming stuff in another solution, it's probably pretty boring, because why do you want to write another for loop that is something that you've already done before? Like you need a project or something. But then if you're doing a project, too much of the stuff is new. In your intensive mode, you're going very slowly. You're not getting enough practice. If we actually drew this parallel originally from language learning, where in language learning, sure, you want to spend some time learning grammar and pronunciation and new stuff, but most of your time has got to be spent just practicing stuff you know. So reading easy books, doing conversation, watching and consuming media, that sort of stuff. So with our approach in the intensive learning for programming, we hardly have any. It's all extensive, right? Because people don't really read. They don't want to read. They don't want to watch a video. They don't want to listen to a lecture. They just want to write the code. And if you let them do that in a way where the progression is right, they're actually going to learn a lot faster, like a lot faster. So in an hour of playing CodeCombat, your average, say that it's a 10-year-old or something, they could have been taking like their in-school programming class for a couple months and maybe just gotten to variables and if statements. Whereas in the first hour of CodeCombat, they'll have done variables, if statements, and while loops, and strings, and numbers, and multiple arguments. Like they've done all that because we didn't stop to explain what the heck they're doing. We just had them do it. You kind of like show them an example and then you have them do a bunch. So if you ask them like, what is a variable? They're like, what do you mean? I have no idea. But they know how to use it. And that's much more important. So eventually you can maybe sort of add some additional content for people that really want to know, like, what have I been doing? Like, what is all this stuff? But it's much more useful and what we've been focused on to just get them to be able to do it as opposed to knowing what the names are.
Well, it's interesting. You talk about this difference between intensive and extensive learning. I think about like learning to play an instrument, and you spend a lot of time playing scales or just learning to play basic chords or extremely basic patterns. You don't sit down a kid in front of a piano and say, all right, just do what you want. It's more restrictive, and that's where a lot of the leaps and bounds are made a lot of times. But I also feel like there are certain people that do better if they're just kind of given the wide frame of doing whatever they want to, just given a textbook or given Wikipedia and just surf around. But maybe those are the people that aren't that don't need something like CodeCombat to learn how to code.
Well, the people that are freestyling their learning input and mostly just reading a whole bunch of stuff, they're still not going to be getting good at coding until they've actually written a bunch of code. Because even if they have this kind of passive understanding of what's going on, still the mechanics of actually putting it down in your code editor are something that you need to be able to debug. You need to be able to type the right symbols. You need to be able to say, oh yeah, let me just do a for loop here, as opposed to kind of having some knowledge of what a for loop is and when you would use it, but not having done it a bunch of times. There'll still be a point where they need to have that practice. And maybe it's in the process of doing their projects because they're really motivated and they're just going to start with projects. But this is something that keeps programming to like maybe 1% of the kind of population of programmers that there could be. Because what you have is you have maybe 100 people try programming. They're like, maybe I should try this thing. Is this thing for me? And 99% of them are going to be like, so I just printed out the something like I can add two numbers together. Like, what is the point? And then they want to do a cool project. They're like, I want to make an app. I want to make a game. I want to make a website. They go through a whole bunch of like developer setup stuff, or maybe they're doing it online in some place that really holds their hand, and they don't have to do that. But in order to write a meaningful amount of code, they have to get through these initial stages where it's very tough, and you have to learn a lot of background before you can do anything new. And the stuff that you can do at first seems to have no point. So 99% of people are going to churn away from programming forever. They're going to say, oh, this is some really geeky thing. This is not for me. And the 1% who are really smart and they're really obsessed, and so they have a lot of patience, then they're like, yeah, okay, well, this initial part is kind of hard and difficult and doesn't do anything yet, but I can see the path towards making cool stuff. Like, I know it's there, so I'm just going to keep trying. And then they get slowly better and better until they can do the cool things that they want. And there you have a programmer. And probably most of those other 99 people that churned away still could do it, still would enjoy it once they got to the point where they could make great things, once they could do meaningful things with their code. But all the ways that we learn to program are kind of following the path of those programmers that stuck with it initially. So you're kind of forcing them to learn this thing as if they have to be really smart and really obsessed in order to do it. And that doesn't have to be true.
So I'd like to talk more about the technology behind how CodeCombat works. We kind of glossed over this, what happens when a command gets entered, if a character needs to move. And I'm curious about, at a lower level, like what you're doing client side, what you're doing server side, how the objects in the game are represented in the code. Can you give me a better idea of just your code base speaking generally?
Sure. So everything is all in CoffeeScript. And we did that for two reasons. One is when I set up the project initially, I had no idea what I was doing. And there was a project skeleton that happened to have CoffeeScript in it. So that's the language of the project. And the second reason is that our core team are all really kind of technically skilled advanced developers. And CoffeeScript lets you express things more concisely and a little bit more powerfully than just straight up JavaScript, especially at the time when there was none of this new ECMAScript awesomeness going on. And so if you want like a wide appeal base, you would just do it in JavaScript and you would take a few more lines to write out all your stuff. But when you just have some really hardcore programmers on the team building stuff, it helps to be able to really jam it in there densely. So it's in CoffeeScript, and I think it's probably by far the largest open source CoffeeScript project, like several times bigger than the CoffeeScript compiler itself, last I looked. And on the server side, we've got Express and Mongo and Node. And on the client side, there's a lot of Backbone and Jade and Sass and this sort of stuff. So, but it's really fat client. So almost everything happens on the client. The server knows a few things, but we try to keep it pretty standard. And on the client, it's really, really nice to be able to use JSON objects, so JavaScript data format, all the way through from the database to the server to the client to even the front end for editing data. We have like an open source library, Trima, which just given any JSON data and a schema will give you a visual interface for editing that. And that's been really, really helpful. So, but that's not really quite enough to just have these JSON things. You kind of need a schema to go with it. So we do a lot of stuff with JSON Schema, where we kind of have this advanced kind of validation and schema framework that can apply anywhere from the database to our front end data editor. And this is really helpful because when you're configuring an object in the game, like your hero stats, I can just say like in my visual editor for that guy, which lives in the website, I'm configuring that, okay, well, he's going to move at 8 meters per second. And I'm going to save that to the knight thing type. And that'll propagate and make all the knights throughout the game move at 8 meters per second. And in some sort of level, I might configure that knight to say, okay, well, on this one, he's going to move at 10 because 8 is kind of slow for this level, which otherwise would take a long time. So we have several layers of just configuring things via JSON, which we can do in this visual editor and so straight to the database, which is really nice. The level editor itself is kind of then makes a big level with this entity component system, and all this stuff is kind of the components are coded in CoffeeScript inside the level editor. So you have this really cool live coding thing that you can do where you're previewing your level. You edit the code of maybe the attacks component to make it so you have to get a little closer to the enemy before you can attack, or maybe you measure the distance from the edges instead of the centers for melee attacks or something like this. And you just edit the code and hit play, and instead of having to reload anything, it's sending all the code for those components over and to your preview window for that level, which also is a live coding environment. So you don't even have to rerun the level. You're just all of a sudden you see what happens when you've made that change. So it makes it really, really fast to iterate and develop in because you're not having to really compile things and reload.
We'd like to take a moment to thank our sponsor. DigitalOcean offers simple cloud infrastructure for developers. In one click, you can have a mean stack, a Rails application, an Ubuntu box, or another custom environment. Software Engineering Daily is proud to have DigitalOcean as a sponsor because DigitalOcean is the simplest cloud service provider. I've interviewed Moisey Aretsky, who is a founder of DigitalOcean, and he told me that DigitalOcean was based on this realization that other cloud service providers are so complicated. If you want things to be simple when you deploy your application, use DigitalOcean. To try DigitalOcean, go to digitalocean.com and enter promo code SEDaily. That promo code is one word, SEDaily. Now let's get back to our show. Is this the first full stack JavaScript application you've written, or have you been writing full stack JavaScript for a while?
Yeah, the previous startup that we worked on, which was my first real program, was Python, Django, and App Engine on the server. So only JavaScript on the front end, and much fatter server, right? So yeah, a lot of this stuff was new to me 2.5 years ago when we started the project. And so it actually took me 9 days to get the basics working because I was still confused as to what code is on the server and what's on the client? What is going on? This sucks. But now that it's all set up, it's amazing.
Well, so maybe there's somebody out there right now who is listening to this and they're about to start a project and they're thinking, oh, I've been doing Django and Ruby on Rails and stuff for a while. I'm just going to do this. And then they're listening and they're like, oh, what is this full stack JavaScript stuff? Are there any suggestions you would give about how to migrate? Because I feel like full stack JavaScript is still people may have a little more trouble onboarding with it than just doing Rails new and getting started with a Rails application or Django, whatever the equivalent is in Django.
Well, there's definitely differences in how you're going to navigate, each JavaScript module that, there's a huge amount of activity going on with open source on GitHub with JavaScript, and it's really great. But that does mean there's a lot more modules instead of a monolithic Rails or something, because you're going to put together Express and you're going to put together a whole bunch of other packages. And, on the client, there's going to be a zillion of them, right? But that's going to happen as well on the server. So I think it's just as easy to get started with Node and Mongo and that sort of stuff on the server, but it doesn't come with as much included. So if your app is super simple at first, great, it's really easy. If you want all that out of the box goodness that's going to come with Rails, that's not going to be there. And you're going to have to go and like pick and choose various packages to get started with that.
And that's the only way to learn.
Well, it's nice to keep things smaller than, and add things as you need them, because then you understand everything you need. You don't end up with this extra stuff. It's much easier to swap components in and out. But it's still nice to start with a nice project skeleton. So, if you figure out which kind of build architecture you're going to use, like Grunt or Webpack or Brunch. We use Brunch. And it was really nice because when we started, with Brunch, there was just project skeletons that had a bunch of the basic stuff set up, and you can kind of choose, mix and match from the technologies and languages you wanted from those skeletons. And so getting that thing set up was actually pretty great. I just was pretty incompetent at the time because of my experience with the Django and not really knowing like client-server difference between my JavaScript. I was also trying to do some really crazy like multiplayer networking like straight off the bat, which was also making things difficult with like operational transform and live editing. I don't know why I tried to do that stuff in the first like 9 days of the project, but I did.
So can you talk more about if you remember any of the misconceptions that you had about web development from programming in Django, where you have all this stuff that's done for you, rather than having to pick and choose your components and your build tool? Is there anything else specific that comes to mind?
Well, so understanding the kind of requires and builds steps and like where each module is going to be available was a little bit difficult at first, because you kind of have to understand what your build tool is doing. You're not just necessarily going to run the code that you're writing, right? You're going to package it together, and it's going to require other code and kind of make cool module structure in the client. But that module structure is different from the module structure on the server. And so when we were using Brunch and we had CommonJS requires that were kind of mimicked in the browser, then that's a different require than actual Node requires on the server, but I didn't realize that. And so I was trying to acquire modules from one place or the other place, and you can do it, but it's slightly different. And there was that one layer of magic there that slowed me down for a while.
I see. Can you talk a little bit more about the front end rendering stuff and like how you made all the pretty animations and stuff? I think you're using Create.js for most of that. Is that accurate?
Yeah, that's right. So I really like that framework for doing a lot of front end stuff. So Create.js consists of easel.js, which is kind of higher level API for Canvas that mimics the Flash APIs, which I happen to know pretty well, having done Flash stuff for the previous app. But even if you don't, it's really, really nice front end thing. And then there's also Sound.js and Preload.js, a lot of the things that you need in order to do kind of rich HTML5 based apps. And yeah, I totally recommend using those. Of course, there's a lot of good stuff out there as well.
Yeah, I've seen some tutorials for those tools, the Create.js suite of tools, and they're really nice. Like the APIs are really nice, and they're just fast. And I was kind of blown away because I didn't realize that such a robust set of animation tools existed for front end development.
Yeah, so
cool.
People love to hate on Flash, but Flash did have many, many iterations.
Oh, yeah.
Figuring out which APIs people wanted and how to organize them.
And it was fun.
Yeah, and the performance was really good and most of the time, except on mobile. And so Flash kind of died, and part of its transition, even HTML5 stuff with Easel.js is kind of its successor. So actually now the Adobe Flash authoring tool will export straight to HTML5 using easel.js. And so, you can take all those animations and that great pipeline for making those, and then still just straight up now use Canvas with that. And so the Flash players is not in the picture anymore. So you get all that portability. And it's just done with straight JavaScript and Canvas. But then you still have the really, really well-tested, great method of organizing your code and of your asset pipeline.
Have you dealt with any interesting distributed systems problems in CodeCombat, or maybe maybe interesting race conditions between different characters? I guess those are two distinctly different questions, but I see them as somewhat interrelated.
Well, let me just tell an interesting piece of the architecture, which we do, because our server is pretty simple. And in fact, we can serve, 8,000 concurrent players in this really rich kind of high bandwidth intensive networking kind of app with just a couple servers. And it's really boring, right? In terms of how easy it is to scale up. But one of the ways that we do that is by doing everything on the client. So there's this multiplayer tournament system where when I submit my code, it's going to play against you. It's going to play against everyone who submitted on the other side. It's just going to play many, many matches, right? So the more matches that you can play, the more interesting it is, because the faster your code can get ranked and you can climb the leaderboards, and the less time you have to wait to find a new player that's actually beating you to try to beat them. But we don't want to do this on our server because simulating all those matches would take a long time. We'd have to run many, many servers. And so instead, we do them on the clients of other players. So when you submit your match and you're sitting there on the ranking screen, it'll say, hey, do you want to help simulate games? So we send over the transpiled code that you wrote along with the transpiled code that someone else wrote in sort of this matchmaking system. And everyone's browser will ask, hey, what's the next game to simulate? And they'll get one of these matches that is waiting. And then they'll kind of simulate in a web worker what happens. And then they will kind of pull out the results of who wins and send them back to the server. And so we have this huge crowdsourced simulation network of basically all the players who care about the arena rankings. And the more games you simulate, the more gems you get. It's actually pretty cool because instead of, we're simulating many hundreds, I don't know, maybe even thousands of games per minute. But we're not running any servers to do that.
Yeah, you should bundle in a little Bitcoin mining in that web worker.
That would have been a great idea 6 years ago.
But I guess that's probably not the best idea in an open source project.
People have suggested it. I think they'd be happy to see something just technologically interesting and cool as that. Being
aside from the fact that it might crash their browser.
Well, so, you use one core and one web worker thread. And typically people that are doing this have more than one core, right? So if they want to slow down their computer, they can just open a thread for each core and then really slow it down. But if they're just running one, typically it's not a big deal.
Right. So I'd love to get more of an idea of your inspiration. I imagine you must have played some games growing up. So what games was CodeCombat inspired by?
Well, visually it was inspired by Kingdom Rush, which is this hit tower defense game for iPad. Well, I guess it used to be a Flash game before that too. And we kind of liked the art style, and our wives liked the art style. So we're like, man, what a great art style. Not only is this easy to draw, but it's not just us that likes it, right? So we kind of shamelessly told our illustrator to kind of use that style. And we originally thought okay, well, a lot of the mechanics are going to be tower defense. And it turned out that it's more like a dungeon crawler RPG at first, and then it switches more to an RTS. And, we'd of course played tons and tons of games. So we take inspiration all over the place. But, visually it's kind of like Kingdom Rush, and then the rest of the mechanics are, everything, right? There's there's a degree to which in the future I want to make crazy persistent world MMO Minecraft mode, but I have to hold off until I get a bigger team because that's pretty crazy to do right now.
Well, that's how you get to building Slack.
Yeah. There's the Slack guys just trying to improve their communication on the side while working on a game or something like that.
Oh, yeah. No, I guess you don't know that story. So, like, Stuart Butterfield, so first he tried to do that in, like, 1998 or whatever, and then, like, the project totally failed. He tried to build this massive MMO thing, and he totally failed, but then he, like, pivoted into Flickr, so he turned it into Flickr, and then, sold Flickr, and then, I don't know, X years later, he tried to do it again, because he's like, okay, now everybody's on mobile, things have changed, so they try to do it again, it fails again, and they pivot into Slack. So it's pretty.
I don't know if that's a pivot so much as like a leap, a giant leap. That's not,
sure.
I mean, keep one foot on the ground when doing that.
Well, I mean, so they had Slack built internally, and then they just like stripped the externally facing product down to just what was previously an internally facing tool.
Okay.
Yeah, but I mean, as far as like building the massive MMO, I mean, so are you inspired by like World of Warcraft or Minecraft or any of
yeah. So I could go on and on and on about that, but I would probably take the next hour without pausing for breath. I'm so excited about this. So let's probably not spill all my secret dreams for this kind of CodeCombat next version.
Oh, okay. Sure. Well, one thing that's interesting I think about is like, there's these different types of games. So like, when I think about like World of Warcraft or Minecraft versus a game like maybe StarCraft or I don't know, other games, poker or something. There's a difference between competitive games or like, I don't know, more zero sum type of games and then like cooperative games. Do you have any philosophies on like, do you prefer these games that are kind of win-win, or do you prefer a more win-lose type of competition, I win you lose sort of thing?
Oh, I love it all, but I especially love the competition. Like I must just crush all of my foes and especially crush all my friends. But failing that, or because you have to have a pretty good skill match to do most competitive games, and if it's not skill based, like it's mostly chance, I hate it. But failing that, it's also really fun to do co-op. So you can have a really good co-op story, and that's really good, especially most players don't want the super hyper competitive stuff. Or you can have really good competitive modes. But what I don't like doing is doing competitive modes where there's not much skill involved. So for an example here would be Mario Kart versus Smash Brothers. In Mario Kart, there's almost no skill. And basically if you're winning, you get hit by a blue shell and now you're not winning. And the driving mechanics, like the acceleration, the max speed, it's just all designed to make everyone basically the same. Whereas like in Smash Brothers, you have to be almost the same skill level as someone to have a good match with them. But then when you do, it's a really good match. Like it's super fun.
So I have to kind of disagree with you there, because I think, when I think of something like Settlers of Catan, for example, like I don't like Settlers of Catan. But, the common complaint I hear is that people say, oh, there's too much randomness in Settlers of Catan. It's not a game of skill. But the truth is that, like, yeah, sometimes you just get crap luck and you have to optimize that luck. But the process of optimizing the hand you're dealt is always like, it's always like an NP complete problem, right? It's like you can never do the best job. And I would argue that it's the same thing in Mario Kart. Like, even if you get unlucky over and over and over again in Mario Kart, it's still super difficult and you're still challenged maximally.
Well, I mean, if you compare Mario Kart to any other racing game, like in one, you're going to be very close to your friends, even if they haven't really played nearly as much as you. And in the other, you're going to lap your friends like 9 times. So I guess that's more what I mean. Like the Mario Kart is in most racing games and in like real life racing, the person with an advantage will win every single time. Whereas you kind of bring things much closer together in a more casual game, right? So I don't like the casual game competitiveness where there's enough randomness brought in that you don't really have enough tiers of skill. And so when I'm making games, I like to bring that thing in, the kind of skill-based nature. When you go to co-op, it's different, right? Because co-op, a lot of the rewards is if I do really, really well and my friend does like sort of kind of okay well, it's fine because I can still like challenge myself to do really well. And so when building programming games, it's really interesting to have the co-op mode in a way that each player still gets challenged at the limits of their ability for coding, but then you somehow combine that into a kind of solution where they can play together. And that's what people really want to do.
What kinds of people are playing CodeCombat? Or is it like kids or people of all ages, or what does the demographic look like?
So if you sign up for an account and answer our first poll, you can kind of see the age breakdown. It's a little bit under 2/3 kids, a little bit over 1/3 adults, which is kind of our failing because we designed it just for kids, like 8 to 18. And then we still have all these adults playing it and paying for it and learning to code this way. And it really shows that we need to kind of make a second version like of the campaign that goes much faster than the average 8-year-old can handle, which is kind of more suited for the people that want to have some experience or want to learn more quickly. Kind of separate it out because there is this audience in both places.
You wrote a pretty compelling post titled "Why You Should Open Source Your Startup." Could you briefly outline the logic that you followed when you open sourced CodeCombat a couple of years ago?
Yeah, so we have all of our users as developers or aspiring developers. And we kind of, my dad was a big open source hacker, and he had the Mr. House project for home automation. It's a big thing. So it was always something that was kind of in the back of my mind. I'm like, well, hey guys, I wonder if we open source this. I wonder if some of our players would help us with it or like learn to code by hacking on CodeCombat after they got to the end of our levels or something like this. Plus it'd be kind of cool and good for PR. And my co-founder's like, yeah, I don't know, but isn't it kind of risky? So we asked, we kind of asked some investors, and the investors were like, yeah, I don't have a problem with it. It sounds fine, but like no one really does that. So I don't know. What do game developers usually do? What do they think? So we asked some game developers, and they're like, Matt, no one does this. No one open sources their games. Like, I think it'd be a great idea, though. I don't know. There's probably some reason for it. Like, what do the lawyers think? And so we asked the lawyers, and I guess you can see where this is going. The lawyers were like, no, it's totally fine, but like, what do the investors think? And so we kind of realized that no one open sources their businesses or their games just kind of because no one does it, right? And there's good reasons why it doesn't actually help for a lot of businesses. Like if your audience aren't developers, it's not going to help you. But a lot of the fears around it in terms of like people are going to fork my thing and outcompete me, or it's going to be a legal nightmare, or like investors are going to not invest in this, it seems to just generally not be true. So if your users are developers, then you open source it and you can kind of get a much bigger lever for which to do your development work. Plus, it's kind of cool to be open source. Like people appreciate that. They really get on your side, and that really helps build community.
Well, many of the businesses that I've talked to on this show do have some sort of open source strategy. Like Cloudera definitely comes to mind, or even Facebook. I've talked to Facebook a ton, and ever since they open sourced React, development on that has just gone bananas. It's done really well. It almost seems like if you can sort of look at open source as a North Star from the beginning, it's like a competitive advantage. So like, I was like wondering, like, what's the logical conclusion you can take this towards? And like, I don't know, what do you think would happen if Microsoft open sourced Windows today?
Well, the logical conclusion for CodeCombat is, you see things like Minecraft, when you have all these Minecraft mods. but it's not actually that easy to make a Minecraft mod. And with CodeCombat, you really try to cultivate the developer community and the content creator community and the modding. Like most of our levels that we publish are made by players, right? Because the level editor is open source, and we really encourage that. So, I mean, the logical conclusion is that as your game or your project gets amazing, it just gets much bigger than you. But then if you're running it for profit, like you still get the profits, right? And maybe you can figure out a way to kind of empower your top contributors or hire them. Like we hire, I think most of our employees now, they start off as open source people. And when it's time to hire, we're like, we finally have a role for you. Let's do it. And they're like, yes. And it's much easier, right? As far as what would happen if Microsoft open sourced Windows, I would have to figure out what would happen in terms of because they sell Windows, right? They would clearly not be able to sell Windows anymore.
Well, Windows 10 was a free update.
A free update if you already had it.
If you already had it, yes.
But I, for example, bought it because I had to run boot camp on my Mac to play Battlefield 4, and I didn't. So I had to buy it, right? Mm-hmm. You cut out that entire revenue stream. I don't know how big a deal that is. I mean, obviously they make a lot of money on other things like Office and these sorts of apps and services. So if it wasn't a big part of their business, then I think it would actually be really good, because a lot of things are really important to some people, and then they'll go and fix that, which can't really be important to you as a business. And that's what we found with CodeCombat, right? A lot of developers will come and scratch their own itch and fix things that like aren't really on the top of our roadmap, but then really make a big difference for them. And you multiply that by all of the developers that use Windows, and that can be really, really big. But you have to do a lot of work to support the open source community, because with a code base the size of Windows, like it'd be very difficult to like actually accept any contributions for someone that took the time to understand everything and work with your development process and that sort of thing. So not really sure how easy it would be for them to like really do it, because they could nominally do it and get some good press, but that wouldn't really work, right? No one would be contributing because it would still be difficult to contribute. But then in terms of they wouldn't be able to sell it, and then there would be a lot of overhead for like developers trying to contribute, and they haven't really set it up for that. It might be too big at this point, but you can open source more and more components, or you could open source the whole thing if it made sense for you to have third parties kind of being able to do their own Windows builds, which for Windows doesn't make sense because they want to sell that.
Do you think everybody should learn to code?
I think everyone should try it. Well, not everyone. So like people that can't read yet, of course, aren't really going to have a good time. They can try the blocks thing or something, but and if it just really, really doesn't sound interesting to them, then sure, skip it. But they're going to have to try it at some point in the future, because over the next few years, you're going to see coding as a core subject basically everywhere. It's already happening in 22 countries and 4 cities in the US, right? So it's getting big, and you're going to have it just be like math or reading as like a core subject that everybody does. So everyone will try it. And I think it's fine if people that try it don't actually like it and they don't learn to code. But a lot of them will, because it is like magic, right? It's like wizardry. Mm-hmm. It's the tech skill that you're kind of analog of all the fantasy books that you read, where people get sorceress powers and like unique skills and stuff. You can actually just create something just by thinking it, right? Your imagination is your constraint only. Like, it's really cool. It's economically competitive. It's a lot easier to learn. It can be a lot easier to learn than people are thinking. It's not just a geek thing. The future is bright for a lot more people getting into it.
How do you think that sea change will happen? Do you think it'll be like, like for example, people think about, basic arithmetic that generally don't think, oh my God, basic arithmetic, I'm not going to touch that stuff. But, like basic coding, there's still plenty of people, maybe not like super young people at this point, because it's kind of been a sea change there, but like, people our age, for example, like I know plenty of people who are just like, oh, coding, don't want to touch that stuff still. Like, how do you think that will progress over time?
I think it's probably pretty similar to math. I mean, people don't think like, I'm not going to do addition, but they're not thinking of addition as like the useful subset of math that they actually like. They're thinking of it as like this monolithic math thing that they have an aversion to. They have an UG field around this. So they're like, math, I'm not good at that. And this is something that they learned early on in school, probably. School tends to do this with many, many areas. So it probably is going to be something where like it becomes like less and less common to find people as you go down the age range who say like, yeah, I don't like coding. Like, I'm not good at coding. And as you go up the age range, I think people will get left behind. You know, anyone who wants to, of course, can break into it, but they've kind of ossified in terms of thinking like, oh, this is coding. It's not for me. That's for like young techies.
Yeah. We did a week of shows about Y Combinator, which is the startup accelerator that you were a part of. And we talked about the engineering behind these different companies. And we always asked this question, what was the most counterintuitive thing that you learned while you were at Y Combinator?
Let me think a minute. I guess it should have been obvious to us, but most of the most successful, best growing apps are business to business. So all the startups that are B2B have a much easier time, and then our business to consumer apps, it's just so much easier to make money. Now, Y Combinator will still have an emphasis, and any investor will still have an emphasis on B2C because you get really, really huge apps sometimes. Like you'll have your Uber or your Airbnb or something. It'll be a huge success. And in the media and of course the sorts of things that you're actually exposed to, of course, it's almost all B2C. You're like, this is what a good app is. This is what I want to make. But that ends up with like most people, if they want to scratch their itch and make something and they have an idea, it's like a B2C idea, and there's so much competition and it's so difficult to get end users to pay for anything that it's just a much harder route to take. So going through Y Combinator and seeing all the B2B companies in there was kind of eye-opening and something we probably should have known before then.
Interesting. Well, Nick Winter, it's been really great talking to you about CodeCombat, and I wish you the best of luck in the future. Thanks for coming on to Software Engineering Daily.
Yeah, Jeff, thanks for having me.